Alright, so this video will be focused on writing equations and creating tables from patterns, tile patterns in particular. So here's our tile pattern. We are shown figure 1, 2, 3. And here's the table that is somewhat filled in. We need to figure out figure 0 and figure 4 so that we can complete our table. All right, so we are going to think about two questions. How is the pattern changing, and what happens if I work backwards? So let's focus on how the pattern is changing first. If we figure out how the pattern is changing, we can figure out figure 4. So what is changing each time? So if we look, each time we're adding 3 more tiles. So to get figure 4, we're going to take figure 3 and add 3 more tiles to it. So now I have figure 4 by adding this to the next. So now what happens if I work backwards? So since I'm adding 3 each time, if I work backwards and took away those 3, it would tell me what figure 1 is. If I take away this 3, I'm left with these 2 tiles here. All right, so now I have my figure 0, 1, 2, 3, and 4. So now it's time for me to fill in my table. So I'm just going to fill in my table with the number of tiles that I have. So if we look here, X is my figure number, where Y is the number of tiles I have at each level or in each figure. So we're going to count these. So figure 0 is 2. Figure 1 is going to be 5, and we're just going to fill them in our table. All right, so now our table is all filled in. 2, 5, 8, 11, and 14. Our next step, what would figure 100 look like? How many tiles will be in figure 100? And in order to figure out figure 100, we have to figure out any number. And to do any number, we have to do our equation. So we're going to use these patterns to figure out what our equation should be. So to begin our equation, we need two different values. We need our starting point. At figure 0, or when x is 0, how many tiles do I have? So my starting point is 2. Now we have to look at our rate of change. What is happening each time? So my rate of change is 3, because I'm adding 3 each time. Now at this point, we can go ahead and build our equation. Our equation would be y equals my starting point, which is 2, plus my rate of change times what figure number I am in. The reason why that would work, because at figure 1, I have 1 set of 3. In figure 2, I have 2 sets of 3. Figure 3, I have 3 sets of 3. So that's why that works for us. Now, we are not to the point where we're talking about slope and y-intercept and all of those things, but we're going to also go ahead and write our equation appropriately. It should be written y equals 3x plus 2, because it is in slope-intercept form. Now we're to the point. So we have for x, it is going to be 3x plus 2 and I didn't give you slope-intercept form, which is y equals mx plus b, where b is our starting point or our y-intercept, and m is our slope or our rate of change. So now we have to figure out what would our pattern, or how many tiles would our pattern have at figure 100. And to do that, all we do is substitute the 100 in for x. So for figure 100, we have y equals 3 times 100 plus 2. 3 times 100 is 300 plus 2, 302. All right, so let's wrap this up. To find the next figures, you need the rate of change. The rate of change is just how the pattern changing for each figure. To find figure 0, the starting point, you have to work backwards. Take away what is being added each time. Finding the figure 0 is needed to create that equation. Figure 0, our starting point, is usually our constant, or our b. The equation format is change times figure number plus starting point, or y equals mx plus b, which is known as the the slope-intercept form. The equation can be used to find any figure number. That's how we work smarter, not harder.